This first page that you see on this supplemental packet is pretty much the same thing you saw yesterday. I noticed that on the top there's like a graphic that I don't believe was there yesterday. You can compare, but it just talks about the correlation coefficient, and you know what I said verbally to you yesterday, that it illustrates it in a graphic. Okay? If you have an R of either +1 or -1, it should be like a perfect line. It's just a matter of what direction it's going. And then the closer that you get to 0, the weaker you get. So I believe we did all of these. So I'm ready to start on page 2. Any questions on? Because we did the first page yesterday. Um, so if you look at number 1, I don't think this was the same one as yesterday, but it's very similar where there's a matching component where you should be able to look at them and assign an R value. Like you're not calculating these R values yourself, but you're just assigning them kind of by matching. So I would start with the strongest one, which here appears to be the strongest lines, B and D, right? Where B is clearly going in the negative direction and D is going in the positive direction. So what's the strongest negative line here? Negative 0.96, that would have to be B. What would be the strongest positive correlation coefficient? 0.98, so that would have to be D. So that leaves either A and C as the last two. And it looks like A is definitely going in the positive direction. It's not as strong as D is, but it looks like A is going in the positive direction. But C is all over the place. Who knows if C is going positive or negative? Now, I only have positives left to choose from, but definitely out of the two that are left, which one is the stronger one? Out of the two that are left, the two numbers that are left. No, we talked about that, the picture. I'm talking about these numbers, which is the stronger number, 0.61. So that would have to be A, which would mean that C would have to be 0.17. All right, these I'm just going to do verbally. It says to describe the strength. So scatter plot 1. You can say like, really strong, kind of strong, weak, none, positive, negative. So what are some words you would use to describe scatter plot 1? Yeah, I'd say it's pretty strong. It's not perfect, but it's fairly strong and it's positive. How about scatter plot 2? Yeah, very, very strong. This is almost a perfect straight line. So very, very strong, also positive. Well, how about 3? Yeah, and yeah, it probably is positive, but it's pretty weak. It's pretty weak. I would say it's probably going to be less than 0.5. You don't have to worry about calculating, because you would use a graphing calculator for that. It's called a linear regression. Some of you that have graphing calculators, you might want to play around with it and do it, like learn how to do it, but you don't have to. How about 4? Yeah, that's all over the place. That's the weakest one we've seen so far. That would be somewhere close to 0. Could fall on the positive side, could fall on the negative side, but there's very little that's linear about number 4. How about 5? It's probably going to be negative because remember we talked about with these scatter plots, you want to have the same amount above and below. So it'll probably be something like this, I would guess. But I mean, it's pretty weak. Regardless of what it is, it's going to be pretty weak. How about 6? It's definitely going to be negative, and it's strong. It looks like it'd be bigger than negative 0.5. It'd be closer to -1 than it is to negative 0.5. But it's not perfect. There's some points that would fall off the line. We're going to talk a little bit more as this thing goes on about drawing the line of best fit. How about 7? Yeah, very, very strong. Almost, it might even be perfect. Might even be a perfect -1. And then how about 8? Yeah, positive and fairly strong. It's probably just a little, probably in that like 0.7 range around there. Okay, let's go to the next page. A baseball coach graphs some data and finds the line of best fit. Makes life easier when they already write it for you. Looks like the Y got cut off. Where X is the number of times to bat and Y is the number of hits. How many hits? If I want to know how many hits, which variable are we solving for? If X is the number of times up to bat and Y is the number of hits, what variable are we solving for? Y. That makes life easier because that's the one that's isolated. So you would put Y is equal to 0.32 times 175 minus 20.51. Caleb, you okay? Those taste better if you eat them. 0.32 times 175 minus 20.51. I'm getting about 35. Number 2, below is a table of data regarding the cherry blossom trees in Washington, D.C. Make a scatter plot of the given data. And then they want you to give the correlation, but we're not going to calculate the correlation. We can at least talk about how strong it is. So one of the axes would be average temperature, and then the other one would be the date in April. Date in April that trees bloom. April. The heck does that mean? Date in April trees bloom. You know what that means? But I don't know. This is date. It doesn't say number of days. Because the average temperature and then the date in April trees bloom. I don't know. I don't know what it means, but whatever. Look, the point is, we need to assign an axis, right? Even though I can't, I'm not understanding what they mean by that second row. Maybe, yeah, like that's the only thing I can think of with this. So like on the 28th, it had so maybe on those were the dates where it bloomed. I guess it doesn't really matter. The point is, um, of those two rows, okay, which one is? So it's hard to understand which one appears to be a time, a measurement of time. Yeah. Time? The date appears to be the time. So I would not, I guess not because you have to, but I would assign that as the horizontal axis. You know, the most common thing you see a horizontal axis is anything associated with time, and then the vertical one then be temp. So we'll do temperature this way, we'll do date this way. We need an interval. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think 4s would be good. 4 would be good. So let's see how that works. 4, 8, 12, 16, 28, and then 12. Wouldn't be enough. All right, let's do 3 then. Let's do by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 28, 32, 35. No. 27, 30, 33, 36. I have to do it by 3s. And then the temperature, if it's going up more, the same thing, we have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. I want to go up to, so let's go where every 2 counts as 1. So 1 degree, 2 degrees, 3 degrees, 4 degrees, 5 degrees, 6 degrees. So the first one is 1.5 on the temperature and 28 on the date. 28 will be somewhere here. Around there. Can everybody see that? 5.8 would be at 3, so 3 and 5.8. Oh yeah, let's see. I don't know what's ahead of me. 2.4 and 25. 25 is over here. That appear to be negative. 4.0 and 21. 4.7 and 14. That 5.4 and 8. 3.2 and 20. And then 5.0 and 6, 5.0. So yeah, that definitely looks negative. It looks pretty strong. One of the things we'll also talk about, it's not just a matter of getting the same amount above and below the line of best fit, um, but it's also trying to pass through as many points as possible if you can. That's what we're about to start doing, is finding the line of best fit. So the line of best fit looks like it would be something like that. Because if I draw it that way, I'm passing through 2 points. How many points do I have above the line? And how many do I have below? No. I have 2 points on the line, and then it looks like I have three just below, three below, and three above. So something like that would be the line of best fit. But anyway, it's clearly a negative correlation, and it's pretty strong. It'd probably be like in that negative -0.8 range, something like that. But we don't have to worry about calculating it. Any questions? Chang wants to know if he is improving his skill on the cello. He created a scatter plot and drew a line of best fit. Um, Conveniently, they've already labeled two of the points there for you. So if he uses those points from his line, which equation? All right, so this is now back to first semester. When we did linear regressions, it wasn't with a scatter plot. It was with 2 points. They've picked 2 points for you, so we've already done this. What would you want to find first when you have 2 points? Yeah, the slope. So this would be 8 minus 1.5 over 2 minus 5, which is 6.5 over -3. 6.5 divided by -3 gives me -2.166. So it's either going to be, well, I already knew the slope was going to be negative, but now I know that it can't be C and it can't be B. I could go find the y-intercept algebraically, but I'm looking at a picture. So from the two options that they're getting, like now, if they didn't give me multiple choice, yeah, I probably had to find it algebraically. But since it is multiple choice and this line is headed this way, does it seem more likely that it's going to pass the y-axis at 12.3 or at -9.35? I would say 12.3, yeah. So it would have to be A. Again, we could find that algebraically, but we've done that already. I'd rather devote this time to something else. So would Shobi.
How are the Smarties? Pretty good. They're not as good as the Sweet Tart ones. Have you had the Sweet Tart ones? Sweet Tarts makes their own Smarties.
You don't even know about that. All right, 4 says the graph below shows the relationship between the distance in miles of a delivery truck traveled and the number of hours that each delivery took. Which of the two given points would be best to use to calculate the line of best fit? Um, the points that the line is passing through. So, which are the points that are closest to this line of best fit? And then it's just a matter of, okay, of those, which is the one that's the most on the line? I kind of like the last two. Is that an option? 600, comma 10 and 700, comma 11. That is not an option. So let's see. 511, let's just do it one by one and then check. 500, comma 11 and 700, comma 11. Well, I thought that's going to be it because they have the same 11. That's these up here. Yeah, we don't want to use those two, so it can't be A. 300, comma 9, which is the one up here. That's not very good. That's not even on the line. And then 407, that's not on the line either. So I probably wouldn't want those. 400, comma 9, which is the one up here. It's a little bit closer to the line, but still not on it. And 511, that's still up here. That's still above. So that one doesn't seem very good either. I'm hoping the last one's good. Let's see. 300, comma 7. 307, yeah, that one's on the line. And 600, comma 10. Oh, yeah. Okay, so it has to be D. That's the only one that's close. If you have any questions, let me know. You guys are being awfully silent. I'm only hearing my own voice. I hate my voice. Jason, you got a question? We didn't do 5, we skipped one? Sorry. Okay, thank you. Jared collected data on the ages and heights of a random sample at elementary school. If he plots the data on a scatter plot, what relationship would he be most likely to see? Okay, so think of it, that's more of a kind of like an abstract question, almost like not rhetorical, but it is something that's really meant to be worked out. So think about it. If we have age and height, which one is more closely related to time? I'd say age, probably we see age this way and height this way. So as you go to the right, meaning as you get older for age, what tends to happen to your height? Yeah. Unless you're Benjamin Button. Have you ever seen that movie? No. Unless you're Benjamin Button, it tends to go that way. So is that a positive or negative? No correlation. Huh? Yeah, it should be a positive. The constant correlation would mean that just your height stays the same, which maybe eventually, as when you get like older, you're gonna stop growing eventually. But at least at first, in elementary school, you grow a lot. Caleb was 6'7" when he was in elementary school. He was. He decided to get shorter. He wanted to blend in more. The graph shows the weight of dogs and the time it took the same dogs to complete an agility course, which shows the line of best fit for the data. Weight and seconds. So isn't that the best? Because I mean, I don't think a dog's weight in pounds would necessarily like determine their agility. I mean, there's some big dogs that are pretty agile, but I mean, by the nature of the question, though, you would think I guess the more a dog weighted, like the smaller dogs are able to jump around more side to side. So you would think the bigger the weight, the okay, well yeah, because we're doing seconds. So the bigger the weight, the longer it should take. Um, but they don't give us the data anyway, do they? Oh, so this is just draw. Okay, I see what the question wants. We don't have to worry so much about the points. They just want to know which one of these would be the line of best fit. Which of these lines appears to A, go through the most amount of points possible, and also try to have as equal amount of points above and below it. Well, see, like option A here is not very good because almost every point is below it. It is going through some points, but almost every point is below it. Why is option B not a very good option? Yeah, almost all points are above it. And it's going through a couple other points, but almost a couple of points are above it. Why is option D terrible? Probably the worst one of all. It's not even going in the same direction as the scatter plot is. So of all of these, the best option, the one that's going to the most amount now, this one appears to have 5 points above it and about maybe 3 points below it. So it's not a perfect balance, but it is going through as many points as possible. So let's see. Have you worked on the homework this week? Lies. 7, a high school principal wants to predict the number of students who will drop out of school so he can get funding for support services. He determined that the equation represents this data, so that's good. They've already come up with the equation for us. Use this equation to help him predict the number of students who will drop out. So this would be much more difficult if all they did was give us the table, and then we would have to come up with the equation. That's what we would need like a graphing calculator for. But since they've already given us the equation, uh, X is the years since 2004, and Y is the number of students. They're giving us a year. So what am I going to plug that in for? What am I going to plug that in for? If they're giving us a year, is that going to go with X or with Y? No, it's going to go with X because Y is number of students. 2012 is a year, but we're not going to put in a 2012 because X is the number of years since 2004. How many years have passed? If you are in 2012, how many years have passed since 2004? 8. That's what you would plug in. I would hope nobody puts negative. That makes sense. So we're really down to either B, C, or D. So negative 10 times 8 plus 216. My math skills tell me it is 136. Why do you think they put that negative 20? Negative 200 2,990. I'm guessing that's what you get if you plug in the full 2012. If you're not even thinking, because somebody just did it just for fun, see I'm right. Do 2012 times negative 10 and then add 216. It looks like there was a typo there because there's four numbers to the left of the right of negative 19. Never mind. Embarrassed. Um, I don't know where they got that then. Which graph represents a positive correlation? That should be easy and obvious by now. If you see, that's the only positive one. The scatter plot below shows an average yearly consumption of bottled water by people in the United States starting in 1990. Using the line of best fit, predict the average consumption of bottled water in the year 2000. So if we just use this line, when the line touches 2000, it appears to be at around 19. 2000. 19,000. If you have any questions, say something. I hate going through a whole paragraph. I only hear my voice. Tomorrow I'll give back the test also. I will do that. Or the quiz, sorry, the quiz from last week. The table below shows the sales for a flour company for the years 2007 to 2012. Answer the given questions. Graph on the scatter plot. Ooh, write an equation for line of best fit. And according to your equation, okay, fine. This is the funnest one yet. All right, let's see. Let's try to draw as accurate a graph as possible. We have again 6, so we can do. We're gonna do years horizontal. I can do the first one is 2007. I'm gonna skip a line, so then 08, skip a line, 09, skip a line 10, skip a line 11, skip a line 12. Oh, that's it. And then going up, I need the moolah, and I'm gonna do by $10. So I'm gonna start off at 300, and then let's just count 1, 2, 3, 4, 5. So this will be 350. 1, 2, 3, 4, 5, 400, which means the top line is 420. So that should work out nicely. So the first one in 07, we were at 305, which is going to be almost pretty much at the origin. In 2008, we were at 330. That's going to be 2 lines below 350. In 09, we were at 345, which is just going by 10s. That'll be halfway. 2010, 370. 2011, 395. That's going to be halfway below half a box below the 400. And then 2012, all the way up to the top 400. So if we were to draw a line of best fit, trying to see how many, it's a pretty good one. If I draw it like that, I'm passing through 3 points, almost 4 points I'm passing through. And it seems like I have 1 point above and 1 point below. I think that's a pretty good line of best fit. Now, in order to be able to write the equation, you would want to pick the 2 points that appear to be the most on the line. This is what I hate about it, because like everybody can get a slightly different answer, depending on what points you pick. Right? They should be closely the same, but unless you have a graphing calculator, you can't say for sure exactly what it's going to be. But honestly, it looks like I could go with. I can either go with these last two. Okay, but even then, like, it's not exactly on a line. Or I could even go, oh, you know what? I messed up. This one should have been a little bit higher. Because I did it too close to it. It should have been a little bit higher. So if I move the blue line a little bit higher, yeah, it's still pretty solid through those points. That's not making much of a difference. So I would go with any of these. Oops, not good. I would go with any of those 3 points. let X represent the years since 2007. And that, yeah, you know what? Since we're starting at 2007, and that's going to be the y-intercept, I'm definitely going to use 305. And then let's go with the first and the last. Final answer. Let's go with those points. So I'm going to use that for the slope, and then I already know the y-intercept should be 305. But that's how many years passed since 2007. So I'll go with this counts as the y, this counts as the x. So 420 minus 305 over 2012 minus 2007. That's going to be 105 over 5, which is 21. So the equation would be y is equal to 21x plus 305. Did I mess up? Oh, okay, sorry. Thank you. So that's 115 and it's 23. So 115 over 5, which is 23, which makes it 23x. And then according to my equation, what would be the sale? When would the sales reach about $500 in thousands? And use mathematics to do. Okay, so now that's just saying to put 500 in for y. So 500 is equal to 23x plus 305 minus 305 minus 305. 195 is equal to 23x divided by 23. Divided by 23. 8.47. So now this is years since 2005. Since 2007. So if I'm 8.5 years past 2007, what year would I be in? I'm in 2007 and 8 years past. That puts me in what year? 2015. And if half a year passes, have I got to 2016 yet? No. So it should be in the year 2015. I added this 8.5 to 2007. So did Jason. Trying to be like me, Caleb? I think you are. There's no hipping or hopping in this class. Mr. Van made a graph to represent his times, blah, 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 which is the correct equation for the line of best fit. Okay. See, this is like the one before where they were nice enough to give us 2 points. Can we tell what the y-intercept is going to be from the line of best fit here? Looks like something just above 55, 56. So really, like this already kind of seems like the best candidate. But just to be sure, let's calculate slope. 65 minus 90 over 7 minus 25 is negative 25 over negative 18. I'm guessing that's going to give me 0.72. It does not. I'm going to 1.4. Huh? So yeah, so it has to be A then. Even though 56 looks like a better y-intercept, 55 is close enough, and that slope can't be 0.70. Am I doing something wrong? I got the y's right? 65 minus 90 is negative 25. 7 minus 25 is negative. Everybody else getting 1.4 for the slope, yeah? So it has to be A. Which relationship shown by the scatter plot? As the cost goes down, the number of sold goes down. As the cost goes, all right, so cost is going to the right. So as we go left to right, cost is going up. So those are the first I'm going to look to. The number sold goes down. It has to be B. As the cost goes up, the number of gym memberships sold, and that makes sense. Who wants to pay more for the gym when you can pay less for the gym? Caleb is so swole that he doesn't have to pay for the gym. They pay him to go to the gym. Which scatter plot best represents the data in the table? I'll let you do that on your own. That's just plotting points. There's nothing crazy about that. That's just plotting the points. Did anybody do that? Did you do that one already, Ann? Are you ahead of us? What'd you get for 13? I'm not too worried about this because it's just plotting points. Ann says A, 10, 2, 47. That's not a big deal. Given the table on the scatter plot, pick 2 points from the line of best fit. And okay, so let's do this one. Let's determine the equation. Which 2 points here appear to be the most on the line of best fit? I'd probably go with the first and the last one. Let's pick those 2 points there. We can tell from the table just below is that 490, 20. And then let's use 2208. So let's use these two for the line of best fit. It looks like my y-intercept is going to be about 22.5, but I'm going to do this one algebraically too, because especially after that last one, I was a little bit off. Let's do this one algebraically. The annual temperature, that's the y's, elevation are the x's, so I got to go then 20 minus 8 over 490 minus 2200. No matter what type of slope should I be getting here? Regardless of the number, what should I be getting? A negative. I should be getting a negative. So this is going to be 12 over, that's going to be a big number. 490 minus 2200. It's negative 1710. So 12 divided by 1710. Woof. So, wow. I'm getting around negative 0.007. We'll just go with decimals because the line of best fit by nature is an estimation. So, and then to find the y-intercept, pick any of the points, and then let's just pick the one with a smaller number. Let's pick this 490 and 20, and then let's use point slope. So y minus 20 is equal to negative 0. Do you remember this from the first semester? And x minus 490. And then just solve for y. Y minus 20 is equal to negative 0.007x. And then 0.007 times 490 is plus 3.43. If I add 20, I'm getting y equals negative 0.007x plus 23.43, which makes sense because my line looked like it was crossing around 22 and a half, somewhere in there, pretty close. Am I going too fast or are we following? Okay, are we talking to headquarters? Yeah.
Red team go. Red team go.
Which graph represents a correlation of this given situation? What? I, yeah, I guess what you're just trying to see which one makes sense. Like, okay, so the bigger your dog gets, does that mean that you buy less food for them? Probably not. Big dogs like a lot of food. Um, the more a plane ticket costs, would you expect there to be more tourists or less tourists? Yeah, so B doesn't make sense. Uh, now this one's all over the place, scattered, but the bigger the temperature, more people go swimming. Yeah, you would think that that should be a positive linear one because unless you like taking a dip in an ice bath, um, that probably would be that should be more linear. And then the number of customers at a clothing store and the amount of clothing sold. Yeah, that one probably would make the most sense. The more customers you have, you would expect to sell more things. So I would say B. The following data table and scatter plot represent the number of negative customer reviews for a given model of cell phone and the total number of the same number that were sold. And what do they want? Just true or false? Answer true or false. Are the points 37,890 and 98,505 on the line of best fit? So 37 is right around between 25 and 50. And 890, yeah, it looks like it could be. And 98,505, 98 would be just before 100. No, that's not even close. No, it would have to be above that line. So this will be false. This scatter plot represents a negative correlation. That's true. It's reasonable to predict that if there are 75 negative reviews, the number of cell phones sold of that same model will be close to 600. So 75, 600, yes, true. That is reasonable. Jada, you look like you don't like scatter plots. Scatter plots love you, though. Below is the number of clothes donated to a New York City homeless shelter. I'll let you do that on your own because we're running out of time. I'm just trying to see if there's anything we can do quick. A keyboarding instructor at a community college. Okay, they give it to you if you are. They give you an equation. If you are 25 years of age, what's your typing speed? Y is the typing speed. X is the age in years. So plug in 25 for X. Negative 1.4 times 25 is negative 35 plus 117.8. So you'd be around 83 words per minute. At the Happy Paper Company, the more boxes of paper you order, the cheaper you have to pay for each box. That makes sense. Using the line of best fit, if your company wants to only pay $5.05 for each box of paper, how many boxes of paper would you have to order? So if you want to pay $5.05, that's right here. How many boxes of paper would you have to order? Well, not 3.5. That's in thousands. So 3,500 is 3,500 boxes. You like boxes of paper, Brandon? Me too. Okay, last one. All right, this will be the last one for the day. And then if you want to do any of these on your own, that's fine. But let's just do this top one. Let's draw the line of best fit here. A point? Is there a 0 point? So line of best fit. Oh. connect these two. I have 3 above, 2 below. Yeah, that's pretty close there. So line up best fit. And pick 2 good points. So let's pick this point and that point. That is a distance of 374 with 125, and then all the way at the end, let's pick those 2. But again, it could be slightly different depending on what you pick. Now determine the equation. So slope is, the y's are the cost of the plane ticket. So 125 minus 250 over 374 minus 1500. Should I expect to get a positive or a negative for the slope? Look at the line. Is that a positive slope or a negative slope? Positive. So 374 minus 15. So I'm getting a negative 125 over negative 1126. So the slope I'm getting is right around 0.11, but I'm rounding. So it depends on where you round, that determines what you would get. Now pick a point. I'll just stick with a smaller one, the 374 one. So y minus 125 is equal to 0.11 times x minus 374. Y minus 125 is equal to 0.11x minus 41.14 plus 125 plus 125. Y is equal to 0.11x plus 83.86, which that looks more or less where it'd be crossing because they're going down by 25, so it's somewhere in that 80s range. It all depends on how accurate my line of best fit was. Try to do the rest of these at home. I'll give you time tomorrow to work on this also, or you can work on your homework too.